If missiles are headed to Guam, here is what could stop them. Hong Kong, North Korea's threat to launch 4 intermediate-range ballistic missiles into the ocean near Guam could mark the first combat test of the sophisticated missile defense systems of the United States and its Asian allies. The launches might not happen for any number of reasons. North Korea's Hwasong-12 missiles might fail, or the United States or its allies could destroy them on the launch pad. Japan and the United States might also decide to do nothing and let the missiles splash harmlessly into the sea. But if the 4 Hwasong-12s do make it off the ground, the options for stopping them mostly rely on hitting them on the way down, in their terminal phase. On the way up, the Hwasong-12, a domestically developed liquid-fueled missile, has a maximum range of 3,000 miles, and hits an altitude of about 470 miles on the way to its destination. The velocities needed for those numbers mean that by the time the missile has been in the air 1 minute, it is already traveling several times the speed of sound. At those speeds, a missile trying to chase and hit it from behind would have no chance during this part of the flight, called the boost phase. The Terminal High Altitude Area Defense System, or THAAD, several of which are now stationed in South Korea, could use its radar to track the launches of the North Korean missiles, but it is not designed to hit them as they climb into space. At one point, the United States Air Force poured billions of dollars into a huge laser mounted on a Boeing 747 that was designed to destroy enemy ballistic missiles during the boost phase. And it worked. But it was so expensive, and required the laser-equipped aircraft to fly so close to enemy territory, that it was abandoned. In mid-flight, once the Hwasong-12's booster burns out and it reaches the edges of the Earth's atmosphere, it is no longer accelerating, but is traveling blisteringly fast and higher than some satellites. This part of the missile's trajectory is called mid-course, and it is the most difficult time for an interception, because a fast-moving warhead can also release decoy balloons that are hard to distinguish from the real thing. But destroying an enemy ballistic missile in space is attractive because it keeps high-speed debris and explosions far from the friendly target. Both Japan and the United States have ships equipped with SM-3 missiles designed for ballistic missile defense. They can hit intermediate-range missiles in mid-course, according to Laura Grago, senior scientist at the Global Security Program of the Union of Concerned Scientists. Most recently, Japan tested 2 of the latest versions, the SM-3IA, against missile targets in space. A test in 2008 used an older model SM-3 to destroy a malfunctioning satellite in orbit, but the trajectory of a Hwasong-12 aimed toward Guam could put the mid-course portion of its flight too far past the Sea of Japan, where the country's ships carrying SM-3s are usually stationed. Intercepting the North Korean missile at this point would be difficult without moving those ships closer to Guam. America's existing system to stop intercontinental ballistic missiles aimed at the continental United States is called ground-based mid-course defense. It is based in Alaska and California, and is not in a position to stop a missile flying over the South Pacific. It also has a spotty record, although its most recent test, in May, was a success. On the way down, as with all ballistic missiles, gravity takes over after the mid-course phase, and the warhead falls toward its target. Some missiles, like the retired Pershing II, can steer during this part of the flight, called the terminal phase. That is not true of the Hwasong-12, whose final destination is determined entirely by course corrections when its engines are still running. Theoretically, that makes it an easier target. The SM-3 can intercept a ballistic missile at this point. The United States Navy does not typically disclose the exact positions of its warships, but several early Burke-class destroyers, which are equipped with SM-3s, are permanently based in the Western Pacific. If they were stationed near Guam, they could take a shot at the Hwasong-12s. It's unclear whether Japan would reposition any of its warships to defend the area around Guam. The THAAD system, of which at least one is permanently based at Andersen Air Force Base in Guam, could also take a shot. That has a good record in tests, most recently destroying a target simulating a missile similar to the Hwasong-12 in July. Finally, the air base may be defended by older, shorter-range patriotic missile batteries, the most advanced of which, The patriotic PAC-3 can also shoot down slower ballistic missiles, worth taking a shot. Missile defense is an attractive but tricky strategy in dealing with missile threats. It has been compared to hitting a bullet with a bullet, and even just testing such systems can be expensive. The payoff, of course, is protection from enemy ballistic missiles, which proved deadly in the first Gulf War despite attempts to shoot them down. If Japan or the United States shoots down the missiles, North Korea could see it as an escalation, prompting a military response. If they do nothing, and allow the North Korean missiles to fly unharmed, it's unclear how Pyongyang would interpret it. On the other hand, if they try to intercept the missiles but fail, it could undermine the credibility of both countries' assurances that their anti-missile systems can work. Some people argue that this would be disastrous for the U.S., Ms. Grego said. Maybe it would cause some to question how useful the systems are, but these are not yet mature systems. I think some failure is possible and perhaps expected, as they haven't yet been tested in fully operationally realistic conditions.